Hey there, mathematicians. Glad you're back. Today, we are going to look at this target. Oops, it moved a little bit. Let's read it together. 1, 2, 3. I can solve complex word problems with an unknown. This sounds awfully familiar and similar to the work that you probably did yesterday. Who remembers what an unknown is? Un means not, and if you know something, right, it's the number that's not known. It's the part that we're looking for, the part that we're missing. Complex is just a fancy word for tricky. So these word problems are going to be tricky today, mathematicians. That means you need to be ready to show some grit and not give up. All right, here we go. We're going to start with this one today. Jim and Nancy collect postcards. They just added 37 postcards to their collection. Now they have 98 postcards. How many postcards did they have to begin with? So let's code the text while we read. Jim and Nancy collect postcards, okay? Doesn't matter what they're collecting. That's not helpful to us quite yet. They just added 37. 37 is an important number, and I'm boxing added as a key word. Why am I doing that? That's right, because it's telling us that we're adding on to another number, but we don't know what number we're adding on to yet. Postcards to their collection. Now they have 98. Now they have, which means their total now is 98. So how many postcards did they have to begin with? So I can tell we are looking for the unknown of the number they started with before they added 37. Our unknown is the number they started with before they added 37. So what do we know so far? If we use our keywords and we see something like add, we know that we're adding another addend on to our unknown to find our total. What equation would you write to show what you already know so far? Pause the video now and write it on the piece of paper in front of you so you can check your thinking with me in just a minute. Is this what you wrote? We have an unknown number they started with. We added on 37, and now we have a total of 98. Nice work if you did. If you didn't, that's okay. We'll keep practicing together. So how can we find this unknown, mathematicians? Think about the strategies you know and the strategies you're comfortable with. We are missing our addend we're starting with. We add on 37 more, and we know we get to 98. I'm going to give you a clue. Addition and subtraction are opposite operations. So just like if you know a math mountain or a fact family that looks like this, we know if 7 plus 3 is 10, then we also know 10 minus 3 is 7, or 10 minus 7 is 3. This is a fact family, and using what we know about addition and subtraction fact families will help us turn this into an equation that we can work with. Oops, too far. Okay. So I am going to rewrite the equation 98 total postcards minus the 37 we know they added later. If I take away the 37 they added later, then we'll be left with the number they started with. So I love number lines because I think it really shows our brain the difference or the distance between what we're looking at. There's two ways you could do this. You could start at 98 and jump back 37, or you can write 37 and 98 and find the distance between the two. All right, here we go. Let's see, if I look at that, 37 is almost to 40, and I know if I'm at 40 and I jump up 10s, 60, 70, 80, 90. If If I jump up another 40, 50, 60, 70, 80, 50 more, I'll be right at 90. So I'm going to start by jumping up 50. 50, jump up 3 tens, 60, 70, 87. Nicely done. Oh man, that is really, really close to 98. If I'm at 87 and I jump up one more 10, so keep the ones the same, jump up one more 10, I'm at 97. I'm only one away from 98. Oh my goodness. So make that one more jump to get to 98. How much did we jump up total, mathematicians? 50 plus 10 is 60. One more is 61. So what is our missing addend here? What number of postcards did Jim and Nancy begin with? That's right, 61. Way to go, mathematicians. Okay, I want you to try this one all on your own. Pause the video now after I erase this mess for you so you can read it. I want you to write down the key numbers. See if you can find those keywords that tell you, are we adding or subtracting? What is the unknown? And write the equation for what you're reading. I want you to pause now, read it a couple times, and see if you can write the equation for what we're looking at. All right, Mr. Taylor has 26 paintbrushes. Mrs. Vasquez gives him some more paintbrushes. Now Mr. Taylor has 44 paintbrushes. How many paintbrushes did Mrs. Vasquez give him? I know that the key numbers we have so far are 26 and 44. Mr. Taylor already has 26. Mrs. Vasquez gives him some more. What do those keywords tell us, mathematicians? That's right. Gives means we're adding, and some more means that's our unknown. We don't know how many more. This is what we're trying to solve. Now Mr. Taylor has 44 paintbrushes. So now tells us that's his new total. I'm going to go back and reread. How many did he start with? 26. Mr. Taylor starts with 26. That's a funky 6. Miss Vasquez gives him some, and now Mr. Taylor has 44. Still think a number line is the best way to go, because if we add on, we can jump up from 26 plus some amount, and we'll end up at 44 paintbrushes. All right, here we go. Remember, the name of the game when you're using a number line is to try really, really hard to get to friendly numbers. So right here, if I add a 4 on to 26, where will I be? That's right, because you know your combinations to 10 and 4 plus 6 is 10, you're going to get to the next 10. If you're in the 20s, the next 10 is 30. That's right, mathematicians. Now that we're at 30, what jump would you make next that could be an easy, friendly number jump that gets you close to 44 without going over? That's right, I would do a 10 jump too. If I'm at 30 and I jump up 10, where will you be now? 40. Nice job, mathematicians. Now, how many more from 40 to 44? That's right, just 4 ones. How many did we jump up total? 10. And I know 4 plus 4 is a double, that makes 8. 10 plus 8 is 18. So how many paintbrushes did Mrs. Vasquez give Mr. Taylor? 18. That's right, mathematicians. Okay, if you're feeling good about this and you're feeling ready, I have a practice page for you. Coming right up. Clean, 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 clean. Do, 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 do. Yeah. All right, mathematicians. I want you to try these 4 word problems. If they are taking you more than 10 minutes apiece, I want you to try 2. And if you're zooming through them, I want you to try a challenge on our website or on our Google Classroom. So mathematicians, here we go. I want you to try these 4 word problems. Write the thinking on a page or a paper in front of you. Or you can do these homework book pages. So you do not have to do both. If you need or want practice in both, you may do both, but you choose what works for you. You can either do these 4 equations here from our workbook, or you can do these 2 pages from your homework book that you have at home. If you're up for a challenge, look for a challenge on our website or in our Google Classroom. And if these are taking a really long time and a ton of grit for you, because we're all different mathematicians, I want you to do 2, show your thinking. And remember, mathematicians, you can always take a picture and post your work to Seesaw for your teachers to see. Way to go, mathematicians.